Well, hello everyone. We appreciate that you've taken out the time to join the July 2026 TAM customer webinar. As always, our goal is to present you with great speakers on topics that are timely and relevant to help you maximize your VCF investment. Before we get into today's content, just a couple of basic announcements. One, as you see on your screen, our next TAM customer webinar will be on August 13th and will be a continuation of last month's webinar on VCF operations, this time focusing on the manage, operate, and protect pillars. We do record every webinar, so if you missed that previous webinar, you can find the recording of it and all previous webinars at the URL on the top of this slide that you see presented, or by scanning that QR code, which takes you straight to the YouTube playlist. Your interaction during this webinar is important. Please make use of that Q&A feature and ask your questions, and we'll try to get them addressed today. If for some reason we're unable to answer those questions today, then be sure and reach out to your TAM and ask them to follow up on your behalf. We'll make sure you get your questions answered. At the end of today's session, you will be prompted to fill out a simple 2-question survey related to the value you receive from this session and any topic suggestions that you have for future sessions. So your completion of this survey is a valuable gift back to us. We'd greatly appreciate it. So that brings us to today's speaker and topic. Féidhlim O'Leary has been a great friend to this podcast over the years, helping us keep track of the new features that have come with each version of vSphere. So we greatly appreciate that he'll be doing that for us today on version 9.1. Féidhlim, it's all yours.
Thank you, Andy. Glad to be back. I always do enjoy these sessions. The audience are always very well engaged. So let's jump into it. We're going to talk about what's new in vSphere as it relates to VMware Cloud Foundation 9.1. This is going to be broken up into 3 main sections, and we're going to start first with lifecycle, right? You can't play with 9.1 until you get to 9.1, and the first thing you're going to need to do is upgrade or do greenfield. So we'll go through some of the new technologies in vSphere that make that a little bit easier. Now, a lot of our customers are still running on vSphere 8.0 update 3. There is a simple upgrade path to vSphere 9.1, right? You don't necessarily have to go directly to the full VCF stack or even the VVF stack. With 9.1, you can upgrade your vCenter, upgrade your ESX, and if you don't already have formerly ARIA operations, you can deploy VCF operations 9.1 to handle that licensing component for you. So you can still keep your footprint relatively small and get access to a lot of the new enhancements and features in vSphere 9.1. And this would be your first step in, let's say, your journey towards the full or the larger VCF stack. Now, one of the great new features in vCenter 9.1 is we're calling vCenter Quick Patch, right? It's very similar to ESX Live Patch that we'll talk about in a moment and that we've released in 8 Update 3. A lot of the similar goals are here with vCenter Quick Patch, right? Obviously, patch cadence is increasing. We released some patches this week. We've released several patches for various different components over the last month, and more are going to come down the line with the advent of AI-driven security vulnerability findings and things like that. So we want to not only be able to deliver the patches quicker to the customer base, but make it easier and less disruptive for those patches to be applied. So in the vCenter space, we're doing that with vCenter Quick Patch. This allows for, so if we take a step back, if we're applying a vCenter patch today, I'm sure you all know the first thing that happens is all the services get stopped, right? Before we do anything, okay, there's a few pre-checks, and then we stop all the services, and then we patch every RPM on the vCenter system, regardless of whether there was actually a code change to that component or not. So a vCenter patch could take anywhere from around 40 minutes to in excess of an hour, depending. Now, we do have reduced downtime upgrade as a method of doing a migration-based patch system, deploying a brand new vCenter instance, copying the data across. And that does reduce the downtime needed to about 5 minutes. But not every customer may have the available capacity to deploy another vCenter and have both of them running in tandem, or we wanted to provide an alternative solution to patching. With vCenter Quick Patch, it's the traditional in-place patch, but we're only patching the code base that needs to be patched. We're only patching the RPMs that actually got a code change for that particular security patch. So that will reduce the overall downtime to anywhere from a couple of minutes to actually zero downtime. So, for example, if there's a patch and it only is targeting something like, let me pick a service like the content library service, for example. There could be a security vulnerability in the content library service. We've issued an express patch using vCenter Quick Patch. Administrators can patch the vCenter, and it doesn't need VPXD to restart. So your main brains of vCenter stays online. In our diagram here, we've got some two users that are interoperating with vCenter. They're still deploying VMs. They're still making API calls while the patch is being applied. So there's no interruption to the service depending on what is being patched. So let's do a quick demo of vCenter Quick Patch so that we can see it in action. Now, this is going to be running just an internal dummy patch. We have not yet released a quick patch compatible vCenter patch right now. So in this example, I've got a vCenter environment. I've started deploying a Kubernetes cluster. And I want to patch vCenter, and I'll show that the actual Kubernetes cluster deployment operation was not interrupted. If this was a traditional patch and VPXD gets restarted, or all the vCenter services get restarted, that workflow is going to fail. It's going to get interrupted. Okay. So I've kicked off my deployment of the Kubernetes cluster. Here it's at 27%. So let's jump to our vCenter VAMI. This is the familiar patching interface for vCenter. There's no change there. And we have our quick patch compatible patch here. We've already pre-staged it just to save some time. It tells us here that there's no workload impact. So that means that the core vCenter services, VPXD, the workload control plane service, WCP, and some others are not going to be restarted. We can see what services, this is some of the operations that it considers workload impact. And we can see the services that are affected by this patch, Update Manager and the vSphere client. Now, you might think, okay, the vSphere client being impacted might impact workloads. Sure, it'll kick some users out of their browser momentarily, but any actions that have been triggered in the UI don't get impacted by the client service being restarted. So the install is the same, except the license agreement. Check the box to say that you did the backup of vCenter, the box that nobody ever lies when they check, and click Finish. So the patching process will go through the same things. There'll be pre-checks. We'll take the LVM level snapshot. We'll stop whatever services need to be stopped, and then we'll patch those services and restart those services. So overall, it will be much quicker patch experience and a much less disruptive patch experience. If we go back to our vCenter, okay, our session timed out because the vSphere client got restarted. But we refresh our browser and the rest of our Kubernetes cluster deployment, it completed without any interruption, right? If this again was a traditional patch where all the vCenter services had to be restarted, that cluster operation would have failed. We would have been in downtime for about 40 minutes, depending on the patch. Okay. So that was a quick demo on vCenter Quick Patch. Hopefully, future patches that we release will take advantage of this. Again, like ESX Live Patch, we're targeting up to 80% of vCenter security patches to be quick patch compatible. Some other enhancements in the area of vCenter lifecycle are we have included RDU with an online depot. So this just makes it easier for any internet connected vCenter instances to automatically pull down the necessary binaries to do the reduced downtime upgrade method of patching vCenter. There is a vCenter virtual hardware upgrade. So this is something that a lot of customers have been asking for a while. And for several years, the vCenter virtual machine itself has been on hardware version 10. And typically, there's no need to change virtual hardware unless there's an actual requirement to gain some new virtualization features in newer hardware versions. But the other reason is that there have been some security vulnerabilities associated with older hardware versions, and we bumped the vCenter hardware version to 17. Now, you might be asking, why did we bump it to 17 and not 20 or the latest, for example? The reason we bumped it to 17 is that that still allows a vCenter 9.1 VM to run on ESX7 hardware, right? So that allows for any customers that are still in a migration phase or transitionary phase, their vCenter may be running on older hardware and they have not yet migrated it to new hardware. We do plan on increasing the vCenter virtual hardware version in future releases as well. Now, when you do a greenfield install of 9.1, that hardware upgrade is taken care for you. If you do a major upgrade from 8 to 9.1, that's taken care for you because a new VM is created. If you're doing an in-place patch, so if you're going from 9.0 to 9.1 and doing an in-place patch, you do have to manually upgrade that virtual hardware yourself. And the upgrade or the patch workflow does alert you to that as well. And there's documentation and KB articles to guide you on how to do that. It's very straightforward. There's a new vCenter resize API. This makes it very easy to, like the feature says, resize your vCenter, change its CPU, memory, and more particular disk size, right? Changing the vCenter's memory and CPU sizing is relatively straightforward. You shut down the VM, increase the memory and CPU in the settings, power it back on. Changing the disk gets a little bit more cumbersome because you have to know which disk you want to change. For example, do you need to change them all? So this API is essentially a one-click change and based on the t-shirt size. You would give the API, here's the vCenter, here's the t-shirt size I want to go to. So small, medium, large, extra large. It will handle the resize of the compute, so the CPU, the memory, and the disks. And it also gives you the option to then defer the service restart for all of that to take into effect, because you do need to reboot the machine for those services for those resize to take effect. And we have additional vCenter maintenance notification capabilities. This is an API or an endpoint that external solutions can actually query to understand if vCenter is undergoing any maintenance at this given time. So rather than vCenter or the external solution receiving, I'm unable to communicate with vCenter or a 404 message, we can actually return a maintenance notification status to say, vCenter is currently undergoing maintenance. Please try again in whatever amount of time. So that's something that external solutions can take advantage of. It's not something that is user configurable. And I know there's a couple of questions coming into the chat. I will pause at the end of the lifecycle section and I'll wrap up those questions before moving on to the next one. So in the area of vSphere Lifecycle Manager, so we've just been talking about vCenter. Now looking at the ESX hosts themselves, we've introduced a new feature. It's a new with an asterisk to it that we're calling zero touch provisioning or vSphere elastic provisioning. And we'll get to that in the next slide. We've introduced image checksums for the image definitions. What this means is that any image definition that you've created in vSphere Lifecycle Manager, can now include a SHA-256 checksum, so that if you're exporting those images and importing them or reusing them in other vCenter instances, you can be sure that the checksums match and the image definition hasn't been changed for whatever reason. It's not a checksum of the VIBs themselves. They're already checked and signed, and we have the checksums on the download portal. It's just a checksum of the image definition. And we've introduced basic kind of validation of firmware and driver for vSAN clusters, even without a hardware support manager. So this allows you to do that first level hardware validation checks against the HCL without needing to have a hardware support manager, because sometimes they also incur an additional license cost from the respective vendors. Now, this won't let you patch your firmware or your drivers for vSAN in that same fashion that is needed with the HSM, but it will allow you to view the current firmware and drivers for the vSAN clusters and get first level HCL validation. And we'll be able to check against the HCL automatically to tell you your current firmware driver is certified. If it's not, it would be up to you then to patch that either out of band or invest in a hardware support manager to help you do that. Okay, zero touch provisioning. This one I feel has gotten a little bit of a slight misunderstanding out in the field and out in the customer base, right? I want to preface zero touch provisioning as that it is almost functionally identical to, or the end result is almost functionally identical to what you can get today with auto deploy stateful install, right? And that includes auto deploy stateful install on vSphere 8 and 9.0. What 9.1 introduces is zero touch provisioning using a new boot protocols. So auto deploy uses PXE based boot protocols. Zero touch provisioning uses UEFI, so it doesn't support legacy BIOS. It only supports UEFI and HTTPS boot protocols. With that, with UEFI, we also have TPM and secure boot support. And it only interoperates with vSphere Lifecycle Manager images, so no update manager baselines. And it gets its configuration from vSphere configuration profiles, so no host profile interoperability here either. And there's no TFTP requirement. You don't have to do that double hop for booting the host to TFTP and TFTP redirecting you to vCenter. We boot directly and we talk directly to vCenter. So it would look something a little bit like this. vCenter will push down the image, the cluster, and the configuration. So I'm going to give you a little demo on zero touch provisioning as well. So let me just make sure I bring up the right one here. Okay. Now, before I get into the demo as well, the one other major caveat with zero touch provisioning, and this is true for auto deploy stateful as well, is that because as part of the workflow, the host will automatically join vCenter, they'll automatically join a destination cluster, they'll become vCenter inventory objects. And if you're in the VCF world and you're using VCF operations to commission hosts or build a new workload domain with these hosts, you're going to run into a chicken and egg scenario where you cannot commission hosts to be used in a workload domain if they're already joined to a vCenter. So if you are planning on using zero touch provisioning to do your ESX installs, you would then have to remove those hosts from their target vCenter in order to then commission them using VCF operations, using those SDDC workflows. So in this example, we have our vSphere environment, vCenter environment. We have a cluster object created. There's a couple of prerequisites that we need to have already done to have a successful zero touch provisioning cluster built. We need to create the cluster object, and we actually need to have the configuration for that cluster already defined. And this kind of seems, putting the cart before the horse. We do have to have the cluster configuration done before there's even any hosts in the cluster. The reason for that is as part of the boot process, we will push down whatever is the current cluster configuration document, the current VCP document, to the hosts as they're booting. And if you have an empty configuration, because VCP doesn't really start, that cluster doesn't start with default configuration. It actually starts with empty configuration. You'll push down an empty config profile to the hosts, and that will actually override some of the installable defaults, and you'll end up with a boot failure. So we have our cluster object, we have our configuration already defined. Where are we going on this? Okay, so we first need to go to, it's nested under auto deploy. So again, that should give you a little bit of a hint that this is more of an evolution or a step forward of the existing auto deploy. And it's nested in the auto deploy services. So we do need to enable those if they're not already enabled. We select our cluster and we hit enable zero touch provisioning. This will create a quick task that was hard to see there because it went so quickly. It creates what's called a network boot bank within vCenter. Just a little bit of metadata about the cluster, the image that's associated with the cluster, and the configuration. So it's something that when the host boots and it communicates with vCenter, vCenter knows what image, config, and cluster location it needs to send down. After this, it's very similar to auto deploy. We do have to create a deploy rule. We'll just give it a name. Now we can define the rules based on a bunch of patterns or parameters. I'm just going to choose all hosts just to keep it simple for this demo, but you can specify that this rule could apply to only hosts with this MAC address range or this vendor ID or this OEM string, things like that. There's lots of different parameters that you can use. Again, same as auto deploy. We only need to choose host location here for the configuration because the cluster will inherit, or the cluster will inherit the image and the configuration from the cluster object itself. The UI will say that here. So the VLCM image is picked up from the cluster and the host settings are picked up from the cluster. So you don't have to manage a separate host profile, for example. Last thing is activate the rule. This is always a step I forget to do. Create the rule, but forget to set it to be active. Okay, so we'll just jump. Oh yes, I want to show the configure tab because this has the UEFI HTTPS boot URL. And it's always going to be in this format. It's essentially your vCenter IP or FQDN, and then it ends in this .efi file. So that's never going to change except for the IP FQDN part. Okay, so let's jump back to our inventory. I'm just going to bring up the compliance view for VCP. And next, I've got a bunch of hosts here that are ready to boot. So they're ready to boot from the network. And their EUFI have been configured to boot from that URL that I showed you. It's going to be different depending on the vendor that you're using. So we'll kick off the boot process, kick it off for all four. Okay. So they're booting, they reach out to vCenter. vCenter takes a look at some of the host attributes. So the host will actually present some, it'll present some attributes. And if there's a rule that matches those attributes, in our case, all hosts will match our rule. vCenter then will deliver the image, which is being delivered right now. We can see the VIBs are being downloaded from the vCenter URL. It'll deliver what cluster the host should join and what configuration. Now, there's going to be a couple of boot phases here. First is the initial install of ESX, very, very similar to if we had mounted an ISO and done the traditional interactive install. ESX is going to boot, ESX is going to install, and then there'll be a reboot. On the second boot phase, that's when most of the configuration is going to get applied. So it's going to apply the vSphere configuration profile to the hosts. And depending on what configuration you're applying, you might have a third boot phase. The reason I have a third boot phase is my configuration is disabling IPv6, which is just one of those configs that needs a reboot to take effect. But after the hosts have booted, you can see now they're joining vCenter behind, fully configured. And there'll be a last just quick check on VCP. If there's any additional configuration that needs to be applied, it will be applied. The hosts will exit maintenance mode if everything passes, everything's compliant. So we've just booted a 4-node cluster using ZTP, fully configured, ready to go. Like I said, there is that caveat. If you want to use these in a VCF construct and you want them to be commissioned for SCDC clusters, you would have to remove them from a vCenter for that. There is a lot more work that we're planning in this space to integrate ZTP with the VCF, let's say the SCDC cluster construct as well for future releases. So this is more of a, let's get off those older protocols. Let's update that workflow first before we move to the next phase in a future release. Okay. So live patch in 9.1 isn't terribly new. We obviously released it in 8.3 initially. We added more code coverage in 9.0. We've added more code coverage in 9.1. We've also included support for TPM-enabled hosts. I know that was a blocker for a lot of customers to be able to use live patch. They didn't want to have to disable their physical TPMs on the servers to be able to use live patch. You no longer have to make that trade-off. Live patch supports TPM hosts. Expanded coverage in 9.1 includes additional bits of the ESX kernel itself, additional vSAN daemons, some core storage daemons, and additional libraries under the hood. Again, our target is up to 80% of ESX security patches to be able to be used with live patch. The first 9.1 ESX patch that we released a couple of weeks ago was live patch capable. The one that we released this past Monday, I think, was not live patch capable. So it will depend on a patch by patch basis. But obviously our goal is that if we could make every patch live patch capable, we will, but it will depend on the actual payload itself. Now it's enabled by default, and we'll see a little bit about that when we look at the demo in a moment. So I'll talk about that when we get to the demo. Now, in vSphere configuration profiles, we've introduced vSAN integration and memory tiering configuration. We integrated it with zero-touch provisioning, and it allows for VDS bootstrap. Now, you didn't exactly see that in the demo, but what was actually happening under the hood, because my vSphere configuration profile or my cluster configuration had defined a vSphere distributed switch for my networking. So my management, vMotion, my storage, VM kernels were all actually on a VDS. What happens is if we're using that sort of a configuration, vSphere configuration profiles and ZTP will essentially inject a dummy or a temporary VDS to the host during one of those boot phases that we saw. And when the host joins vCenter, it transitions over to the actual VDS that is managed by the vCenter. So that's what we mean by VDS bootstrap. We essentially do a little bit of an inject of a temporary VDS first, and then when the host join vCenter, they switch over to the real VDS that's managed by vCenter. There's also a new automatic remediation function, and this is for new hosts that are joining a vSphere configuration profile enabled cluster. Rather than having to go and manually check config, check compliance, remediate the host, yada, yada, yada. We now have the ability that once a new host joins a VCP enabled cluster, we'll automatically go through that remediation. And if we can apply all the configuration, we will. If not, we'll prompt the user and get them to update the configuration that might be missing. We'll automatically pull out some of the IP address information from that new incoming host. So any VM kernel interfaces that have been created already, we will pull out that IP information and inject it into the cluster, the overall cluster document as well. And in certificate management, I just put this here from a lifecycle perspective. We have automatic renewal now built into the vSphere certificates. The vCenter TLS certificate will automatically renew 5 days prior to expiration, and the ESX certificates will renew 30 days prior to expiration. The ESX certificate expiration date is configurable. I'm not sure why that one is configurable, but the vCenter one isn't configurable. And this only takes effect if you're using VMCA managed certificates, so default out of the box certificates. If you've issued your own certificates, your own internal certificate authority or a public CA or anything like that, we don't touch those. We don't automatically renew those because we can't. This only affects default out of the box VMCA certificates. And if during an upgrade, if you're upgrading a vCenter from, let's say, 8 to 9, and the VMCA root certificate is less than 1 year, it's going to expire in less than 1 year, we will automatically renew that as well, and all the subsequent leap certificates as well. So it's almost like a full certificate renewal during upgrade, because a lot of issues that can happen during upgrade can be attributed to certificate expirations that only tend to crop up when we're doing those upgrades and old certificates get carried forward, for example. Now, this doesn't take away from the larger VCF operations functionality that you can have automatic renewal of all these certificates and more as well, regardless of whether you're using internal VMCA issued certificates or you're using external certificate authority issued certificates. So this is more of a just a very basic auto renewal for those default certificates. But if you are running a larger VCF environment, there is a much more powerful functionality in VCF operations to manage your fleet-wide certificates as well. Okay, so let's do a demo of Live Patch, and then I'll get to some of those questions that are in the chat. Okay, so I'm going to start this live patch from the VCF operations interface. That's just the way I built this particular demo. There's no change to the workflow from the vSphere client, from vSphere Lifecycle Manager. You select the new patch, you hit remediate. There's no change. There's no change there, especially when we talk about the fact that live patch is now enabled automatically. And we'll see some of that UI here as well. So, but if we're in VCF Ops, we've already upgraded the rest of the stack. We're just going to do an upgrade of our ESX hosts in this particular workload domain. And this is just to show that live patch can be consumed by the VCF stack as well. It's not something that you have to go to vCenter to trigger. So we're selecting our cluster. We're assigning the image. So we're assigning ESX 9.1 patch 0100. So that was our live patch capable ESX patch that came out a few weeks ago. If we scroll down, we have an option for image clusters, and this is pulled from vSphere Lifecycle Manager. You would see this exact same settings there as well in vCenter. So live patch is enabled by default. So that box is always going to be ticked. And it has two mode of operations, auto or enforce. Now, right now, I would leave auto as the default. It is the default. This means that if a patch is live patch capable, we'll use the live patch method. If it's not, we'll do the traditional full maintenance mode, full reboot method. So it just allows the system to make that intelligent decision. If you choose enforce, that will only allow live patch capable patches to be remediated. So, for example, if I had chosen enforce here and I'm now on the patch that came out this past week, ESX 9.1 0200, that's not live patch capable, and the remediation would essentially be blocked here. I'd have to go in, I'd have to change the setting or review some things to make it proceed. So there's really not a huge benefit in choosing enforce right now, because we will have patches that are not live patch capable. I would recommend leaving the setting at auto. We have no standalone hosts, and we'll finish. Now we'll kick off the upgrade here. VCF Ops does have some view of what's going on here, but we'll jump to our vSphere client. So we're patching this management cluster here. It's got all these bunch of VCF management VMs on it, and the image is getting applied that we defined from VCF Ops, and it starts executing the live patch methodology. We see host 2 there has gone into partial maintenance mode. If you're not familiar, partial maintenance mode is essentially a special soft maintenance mode that leaves VMs running on the host, but stops VMs moving in and out from that particular host. So it keeps the status quo while the patch operation is in progress. And because we're not evacuating these hosts of all their VMs, that's really, to me, that's where the benefit of live patch comes. We often marketed live patch along with security because, yeah, patching vulnerabilities goes hand in hand with security. But to me, the real benefit of live patch is giving you back time. Instead of waiting, significant amount of time waiting for these hosts to evacuate all their VMs, and then repopulate so that we can evacuate another host and do that in a rolling fashion, that eats up hours and hours of customer time. By being able to do the patch without having to move any virtual machines, it makes it much, much quicker, gives you back time. So the patch was applied, no VMs moved around. It was now obviously I sped up this demo a little bit, but it does happen in minutes rather than hours that many customers would see. Go back to VCF Ops and it's completed as well. And that's that done. Okay, so that's the end of the lifecycle section. Let me take a quick look at some of the questions here. So question 1, if vCenter 8 is upgraded to 9.1, can clusters with ESX 7 prevent the upgrade? Yes. So if you're on vCenter 8 and it's currently managing some ESX 7 clusters, the upgrade workflow will catch that in the pre-checks, and it will block you from upgrading the vCenter to 9.1 unless those ESX 7 clusters have been upgraded to a minimum of 8. So is there an upgrade from 823 to 9.1 non-VCF a viable option? Yes. So we talked about that at the first one of the first slides. If you're running vCenter 8, ESX 8, you can go directly, like a traditional vSphere install, you can go directly to 9.1. vCenter 9.1, ESX 9.1. The only additional component you're going to need to deploy if you don't already have it is VCF operations. So you will always, every environment will need a VCF operations 9.1. The main reason for this is all licensing handling has moved to VCF operations. Have there been any changes made to the basic requirements on the Microsoft internal CA for VCF Ops to generate certificates? I'm not 100% sure on what our requirements are for that integration. VCF operations isn't my primary product that I do work with, but let me take that question offline. Andy, if you wouldn't mind making a note of that question there from
Got it.
Brandon, we'll take that offline and we can follow up with you. Question from Kevin: Can LivePatch be used if the cluster has NSXT installed? Yes, it can. The cluster we just saw in the demo there was a full VCF management domain. That had NSXT installed. LivePatch is compatible with NSXT, and it can actually LivePatch some of those NSXT VIBs themselves. And there's a question: VROPS 8.18.7 is not currently supported to upgrade to VCF operations 9.1. I don't know the answer to that off the top of my head, or Upgrade Matrix should have an answer for that. If it's a case that I'd need to look up the exact dates, but if VROPS 8.18.7 released more recently than VCF operations 9.1, then that's what we call a back in time upgrade, which we don't support. If it is that case, you might be needing to wait until VCF operations 9.1.1, which would be a future release.
Hey, Féidhlim, it looks like there's something special about 8.18.7. Like it's red, whereas like 8.18.6 and 5 even are green to go to 9.1.
Okay.
So something
Okay.
you
It could be
you
that back in time. So if it came out, if as you said, 8.18.6 is good, 5 and 6.
yeah.
And so
I'll put
7 might have come, yeah, 7 might have come out after 9.1 GA, which means it's a back in time release. So it's technically newer code than 9.1, even though the versions are older, if that makes sense. But we can take that one offline as well, and I'll look up the interop matrix, and that'll answer that. And is there issues when you upgrade from vCenter to VCF 9 and then upgrading? There's no problem going from 8 to 9.0 as a first step, and then going from 9.0 to 9.1. If you want to do that, or if you have a particular reason to do that, there's no issues there. If you don't need to do that two-stop or two-hop upgrade, you can go directly to 9.1 as well. And so we only need to add vSphere operation for licensing. Yeah, so if you're running, let's not to be insulting to vSphere, but if you're running basic vSphere, so just vCenter ESX, and you add VCF operations for that licensing piece, there's really actually, and you're only applying that vSphere level licensing, or even if you have a VCF entitlement and you apply that license, because the rest of the stack isn't there, you'll only get access to the licensing portion realistically within VCF operations. So even if you apply a VCF license to operations and you only have vCenter ESX, you'll still only be able to use it for that licensing portion. So everything else would be done through vCenter, like you mentioned. Okay, so that's cleaned up some of the Q&A. Let's move on to some features in VM management. Oh, yes, and thank you, Rick. Rick just posted a link to the VCF planning tool. That's a nice interactive tool, a web interface tool where you can plug in what products and components you have today, what versions, and it'll give you a step-by-step plan of where to go and how to get there. Okay, so in the area of, and I will come back to the questions as well again at the end of this section. So in the area of virtual machine guest OS, we had a bunch of different guest OS customization options, depending on whether you were using the guest customization vSphere APIs, VCF automation, vCloud Director. So there was a disparity there. So we've consolidated the guest customization features and functionalities into what we call the guest customization vSphere APIs. And some of these things that we've pulled into the guest customization APIs are things like resetting and managing root passwords in Linux, resetting accounts in Windows, executing customization scripts. And in the network space, we now allow for IPv only customization. So in the past, you had to do both dual stack IPv4 and IPv6 customization and then go in afterwards and disable the IPv4. Now you can just do straight IPv6 out of the box. And we also allow for just customizing the network of a VM. This can be a part off or part on VM. So this allows for simplified real-time networking changes. Very useful if you're needing to re-IP a virtual machine, for example. Now, vMotion and DRS, it keeps getting more intelligent, and we have to keep making it more intelligent because the types of workloads that are running on vSphere are changing and have evolved, especially in the last 5 to 10 years with the advent of GPU related VMs and other hardware accelerator VMs and different workloads. So we've introduced this new option when you're entering a host into maintenance mode. Now, the option is called in the UI non-disruptive vMotion evacuation. And I really dislike that phrasing because it implies that the standard vMotion evacuation is somehow disruptive in a way. And that's not what we're trying to get across here. And I am hoping PM will change that wording. I like to refer to it as DRS optimized maintenance mode evacuation. So what it does is if you've got a virtual machine that has a reservation, for example, it has a certain requirement for memory and compute, and we want to evacuate the host that it's running on, but we don't want that VM or multiple VMs on this host to undergo any resource contention, right? If we have a bunch of VMs and we put a host into maintenance mode, we're using the standard vMotion evacuation, DRS will just balance them out. We'll just distribute them out accordingly. And you may have resource contention, right? Depending on the size of your cluster, you may or may not have some resource contention. Now, in this simple diagram I have on screen, I've got 3 relatively small hosts and a couple of VMs. So on the hosts on the right, they're using 40 gigs of their 64 gig memory. The host on the left has 32 gigs memory, and it may have a reservation for that memory as well. So if we were to move it to either one of those other 2 hosts, it's going to have some sort of resource contention. I'm going to overcommit the memory, and it may cause performance problems for that VM. So by using the non-disruptive vMotion evacuation option, what DRS will do before it puts the host in maintenance mode, it will do a rebalance of the remaining hosts. So it'll try and see, can I free up enough space so that the host can enter maintenance mode and we avoid any resource contention? And it does this proactively rather than the standard method would move the VM, I then realize that there's resource contention and then have to do the rebalance after the contention has happened. This avoids the contention from happening to begin with. So now that we've rebalanced the cluster, we freed up some memory, we can put the host into maintenance mode. Now, this does impact all VMs on that particular host that entered maintenance mode. It's not done on a per VM basis. That may be a feature request for future enhancement, but it is to avoid resource contention for workloads when we're putting hosts into maintenance mode. And the other thing that'll benefit maintenance mode, and it's around the vMotion or the batch processing of vMotion tasks. So today, or out of the box default for concurrent vMotions is 8 vMotion tasks at a time for a particular host. Now, in vSphere 9, what happens is if you're doing a batch of, let's say, 16, you bulk select 16 VMs and you go vMotion. these 16 VMs to wherever we want them to go. The first 8 will start, but the second batch won't start until the previous batch has all finished. So there's a lot of time and cycles wasted waiting for that last vMotion to complete. Whereas in vSphere 9, as soon as one vMotion task has completed, another one will slot in and take its place, and we'll just keep rolling through them. So it's much more efficient. There's better resource utilization, and overall should reduce the time to completion for these large scale batch vMotions. Okay, before we jump into the last section on workload acceleration, let me just do another scan of the Q&A. So yeah, we had the GitHub planning tool. So if you Google GitHub VCF planning tool, for those that can't see the Q&A or can't click that link, you'll get the link to that as well. So it's on the VMware GitHub. Is there a way you can set up a lifecycle manager image at a centralized location and use that image for all the clusters? Yes, that is a feature that we introduced in 9.0, actually. So you can define your images, your cluster images. If you go to the vCenter object in the vSphere client and go to the Updates tab, you can see all your clusters and all your standalone hosts in one view, and you can assign images to those clusters from one pane of glass. You can remediate, check compliance. You can do the lifecycle manager tasks all from that vCenter level inventory tree as well. But that's something that came in 9.0. So I didn't talk about it here. Does vMotion start with the largest VMs first? That I do not know. I'm not 100% sure how it would be. DRS would be what determines which VMs. So when you're doing a batch or you're doing a maintenance mode task, I'm not sure the DRS algorithm that would determine which VMs gets moved first versus others. We can try and find that out for you and follow up. And if you want to take a note of that one as well from Michele. Okay. So why keep both live migration options available if the new one seems superior? Oh, so for the vMotion, so it can be workload dependent, right? Sometimes you might want to put a host into maintenance mode, have that host evacuate, and you may not necessarily care if there's going to be some resource contention or not. Maybe it might be a VDI cluster or something where some resource contention isn't going to raise a lot of alarm bells, or you just have no choice and you need to patch this host, for example. So you need to evacuate it. You need to get the patch down. Maybe there's a severe security vulnerability. So you can't wait for the host, or you can't wait for evacuation to only happen without resource contention. So that's why both options are going to still be available, so that you have the choice to either wait or be guaranteed no resource contention, or just power through it and let the evacuation happen. And we have a area operations with predictive DRS with this new DRS behavior. How does this change? I'm not sure. Let me think about that for a moment. Because predictive DRS will try and that I would need to think about and come back offline as well, Rick. I'm not 100% sure if there's really any change to predictive DRS with this new DRS behavior. With the vMotion DRS of batch processing, it'll just interoperate. There's no change there. Predictive DRS won't even be aware. But for the maintenance mode operation, the default maintenance mode state is going to be the standard way. It's going to be the existing method where we don't care about resource contention. We just want to put the host into maintenance mode. That's how I believe predictive DRS is going to operate, because we don't give that choice outside of the UI here. But we can follow up on that predictive DRS question as well. Okay, and we're going to follow up on the certificate one too. Okay, so let's get to our last section, and we'll have a last demo here as well. So workload acceleration, excuse me, there's a lot of talk about memory tiering, right? Rampocalypse is a word I'm sure you've heard. The price of RAM being able to do hardware refreshes and add additional compute is something that a lot of customers are struggling with and may continue to struggle with. With memory tiering, it allows us to use high-speed NVMe devices as a second tier of memory. So essentially, we're extending the life of a server because we cannot add additional DRAM. We're able to extend the compute capacity of the server by adding those NVMe devices. Now, memory tiering was first released in 8 Update 3 and 9.0. There's some enhanced observability built into the vSphere client. So now you can see at a glance at the host and cluster level and the summary tab, some additional metrics about capacity and performance metrics. There's a lot more then that's ingested and viewed from VCF operations. We have a redundancy choice. We have hardware redundancy, or we have software-based redundancy. And when we look at the demo, we will actually look at the software-based redundancy, so that you can add 2 NVMe devices and have mirroring for high availability. The workflow, again, we'll see in the demo, is improved, and it uses vSphere configuration profiles. There are expanded VM interoperability. So what this means is that there are certain virtual machine types, or we call them sometimes virtual machine profiles, that do not interoperate yet with memory tiering. This is out of the box things like VMs that are enabled for latency, high latency sensitivity, VMs enabled with vSphere fault tolerance, nested hypervisor VMs. So for example, something like Microsoft VBS would use a nested hypervisor as part of it. In 9.0, these VMs just would not power on. They would give you an error that they're not compatible with because memory tiering is on the host. In 9.1, these VMs will now power on. They'll no longer be blocked, but it doesn't mean that they're using memory tiering. It just automatically excludes them from the NVMe memory tiering pool, essentially, and allows them to power on as normal. And we're seeing performance improvements in 9.1. And this is performance improvements in workloads that we benchmarked in 9.0, for example. We're seeing up to a 16% or performance gain in some database workloads in our own internal testing on 9.1 compared to 9.0 using memory tiering, and some CPU reduction as well in some workloads, overall CPU utilization. Now, with memory tiering, you have the option to do hardware-based mirroring or now software-based mirroring. The software-based mirroring is obviously a little bit easier for customers to adopt because they don't need to ensure that they have any special hardware controllers. They may not have the space on any controllers to do hardware-based RAID as well. Maybe they're using those controllers for vSAN, for example. And you don't want to mix and match vSAN on the same hardware controller potentially as NVMe tiering. So we introduced software-based memory tiering, and this just lets the ESX kernel handle the tiering itself. So if one NVMe device goes down, the other one is there to take its place, and there's high availability and better resilience. So let's take a look at NVMe enabling NVMe memory tiering in a demo. Okay, so we have our cluster here. We are going to configure NVMe memory tiering using vSphere configuration profiles. So we go to our configure tab and desired state configuration. And if you're not familiar with vSphere configuration profiles, this is the default UI method for doing any sort of modification to the configuration. We would go to the draft tab and we would create a draft. A draft is just a copy of the current settings in a writable fashion. And you can see all the settings are broken up into various sections. We're going to choose memtier for memory tiering. It's currently saying not configured. So we're going to go in and configure its settings. So we're going to enable it true. Now we're going to choose the NVMe devices that we want to use. It's a simple UI-based select. So this host has 2 NVMe devices. We're going to choose the first one. And we'll do that for all 4 hosts. Obviously, the second one is going to be there to be used for our mirror. Okay, all right, I go to mirror device. If you accidentally select the same for both let's say the mirror and the non-mirror, or the primary and the secondary, it will give you an error. It'll tell you that you cannot use the same device. Okay, we hit save. So we'll run a pre-check just to make sure that, okay, the proposed configuration that we want to apply, is there any problems with that? It comes back and there are none. So we will apply our changes. Next. So it'll tell us the 4 hosts will be put into maintenance mode sequentially. We don't need a reboot to enable memory tiering anymore as well. I believe that was a requirement in 9.0. Go to our operation details and our remediation status. Now, to keep it quick, I didn't have any workloads on this cluster to avoid any migrations. And if we jump back to our summary, so now we see on our summary tab, we've got our total memory, but we've got tier 0, which is our DRAM. Tier 1, we have 96 gigs of capacity. Now, obviously, this is just done on an empty cluster. There's not going to be any workloads. No capacity is going to be moved to that NVMe tier. But as we start deploying workloads and as the active memory starts to go above 50% on the cluster or on the hosts, any cold memory, cold pages will start to be offloaded to the tier 1 or to the NVMe tier. So it's always only going to be cold pages, cold memory, cold pages that get offloaded. Any warm or active or hot memory is always going to be kept in the faster DRAM. Okay, let me switch back to the deck. Okay, we just have a handful of slides left, or not even a handful. So the other thing that we've done in 9.1 around hardware acceleration is offloading encrypted vMotion to Intel QAT, or Quick Assist. This is available in, I think, Sapphire Rapids Generation 4 and later CPUs. This allows for hardware-based accelerated encryption and decryption when we're doing encrypted vMotion. So it should mean that the vMotion itself is going to be that little bit quicker, use a little bit less CPU resources, and free up some of that as well for additional workloads. Now, encrypted vMotion, I believe, is set to opportunistic by default. But with the offloading it to hardware, it would be beneficial to set it uh, to to require encrypted vMotion. So if you've got the CPUs that can support offloading the encrypted vMotion, then I would recommend using encrypted vMotion. You're not going to see a performance impact then. Okay, and the last slide we'll talk about is on our scheduler or ESX scheduler. So, or the NUMA scheduler that it can often be referred to. We have now a topology aware scheduler in 9.1. And the scheduler is what is the brains of ESX of how it determines when to schedule what onto the physical CPUs. And as CPUs get larger, get more density, get higher density cores, multi-socket, we needed to evolve and make our scheduler topology aware and be able to be optimized for these new CPU technologies. So with the topology aware scheduler, we have improved CPU and memory, what we call goodness model. So the existing scheduler really only considered CPU contention when making placement decisions. The new topology aware scheduler will take into CPU, but it will also consider cache and memory bandwidth as well when making placement decisions. And there's improved for larger high density clusters as well. Like I said, support for modern CPUs with crazy number of cores in the hundreds. Something that you don't have to turn on. It's not something that you're going to interact with, but if you're doing a hardware refresh and you're getting newer CPUs with high density cores, this is going to just take effect automatically. You're going to see a better NUMA placement decisions by the scheduler. Okay, so that brings us to the end. Let me check the Q&A. There is still a couple of questions. Okay, let me work from the bottom up. Does memory tiering require dedicated NVMe drives? Yes, it does require dedicated NVMe drives. You cannot share the NVMe drive as the boot device, or you can't share it with vSAN. It is fully claimed by memory tiering.
I'll put a link to a doc on that one too.
Good, thank you. And so for expanded VM interoperability, will virtual machines that are identified as ineligible for memory tiering be automatically tag flagged or marked so that they be configured? So there's no user configurable flag or tag that these VMs, let's say fault tolerant VMs, high latency VMs, they're automatically excluded under the hood by memory tiering. Now you can always disable memory tiering at a per VM basis as well. Outside of the automatic exclusion that we do for certain VM types, if you have any other workload or any other VM that you want to exclude from memory tiering, there are two ways to do it. Essentially, there's a flag you can set to exclude the VM itself, or another option is if you give the VM a memory reservation, that will in nature excluded from memory tiering, because that is always guaranteeing the VM that it's getting X gigabytes of DRAM. So those are ways you can exclude a VM from memory tiering. The automatic exclusion is done by us under the hood, and there's no indication to the user that it's really. Yes, you can disable it in the VM setting. It's either at the VM advanced settings, or it might be at the cluster level, and you identify the VM itself. I can double check there's definitely documentation on the exact method to do it, but you can disable memory tiering at a per VM level as well. And how does the optimized DRS do with voice VMs? I assume you're talking about like voice over IP workloads. So you put them into a special cluster that does not allow vMotion. So it probably doesn't change the sensitivity to those sort of workloads, right? Because we're not what impacts something like a voice over IP VM. Those are VMs that are very susceptible to the stun time that a vMotion might go through, and can cause, calls drop and things like that. So the emotion is still going to happen in that what I was calling DRS optimized method or not. So the vMotion process itself isn't going to change. There's still going to be that stun time when the VM is moving from A to B. So it's not going to change your behavior there of not allowing vMotion for those particular virtual machines. Now, with live patch, they should be able to tolerate a live patch, because when a cluster is undergoing a live patch, the VMs essentially have their VMX process very, very, very fast reloaded. It's I have not yet come across a workload that can't tolerate that, but it is something that you may have to test in your own environment. So if you think of when you do a live hot add of a disk to a VM, for example, if you have a VM that's powered on and you add an additional disk or a NIC while it's powered on, that's essentially what undergoes when we do a live patch called a fast suspend resume. It's essentially a very, very quick reload of the VMX process. So if you have VMs that can tolerate that sort of action, I would expect them to be able to tolerate the live patch as well. And in that case, they're not vMotioning, they're just doing a reload. I'm kind of talking to Mark about his question. That would be something that I would urge you to potentially test in your own environment to make sure that those voice application workloads can tolerate that sort of action. Can you share more about the workloads or VM types that get excluded from memory tiering automatically and the reason behind it? So yeah, there's actually a link was just posted to you there from Duncan Epping, his Yellowbricks blog. The reason behind it is that just some workload types are just we have not gotten that interoperability there yet. I think one that wasn't listed as well is VMs using direct PCI pass through, right? They typically will have full memory reservations as well. There's just certain types of VMs that are utilizing either things like high latency sensitivity, where they're so susceptible to latency, we don't want their memory to be moved to NVMe, which is fast in comparative, but it's still a magnitude slower than DRAM. So they may not like the fact that some of their memory is now on a slower memory tier and have to be read back into DRAM to be used. For fault tolerance, it's the same. It's the same sort of thing with that. It's largely because we're doing essentially a continuous vMotion when we're doing a fault tolerance. So again, kind of going into the weeds here, a fault tolerant VM has a primary and a secondary. And when you enable vSphere fault tolerance today, it's a direct replication from the primary to the secondary, and it's a continuous replication. And under the hood, it's actually using technology very similar to vMotion. It's like a never-ending vMotion where we're constantly copying the memory from the primary to the secondary. So we don't have a good way right now to be able to map the memory of one VM of the primary and the memory of the secondary, and where those pages are in the NVMe tier on the source and destination. So there's just some technical hurdles that we would need to overcome, and that's why right now we've excluded some of those VMs from memory tiering until we solve those problems in the future. Yes, we will get a copy of the presentation and recording. And we have multiple vCenters in enhanced link mode. Is it recommended to break link mode before upgrading to 9.1 or after? This, your mileage may vary with this. If it was me personally, I would break them before the upgrade. The reason I would say before the upgrade is if you've got, let's say, 5 vCenters in enhanced link mode on 8, and you start upgrading them while they remain in link mode, you upgrade one to 9.1, you upgrade a second one to 9.1, you get to the third one, and there's an issue, and you have to roll back. You potentially may have to roll back the first two that you already completed, because there's going to still be that uh, SSO domain replication between all 5, even during that upgrade phase. So if it was me, I would break link mode before the upgrade, get all your, let's say, again, your 5 vCenters on their own individual SSO domains. And then you have a lot more flexibility to upgrade them in any particular order, and any upgrade failure is not going to disrupt any of the other successful work or any future work. So essentially creates standalone vCenters. And when you do get to 9.1, you can then do it's called vCenter grouping or vCenter linking in VCF operations. If you have the you can add those to vCenter linking to get single pane of glass. And I believe actually that is available even for the non-full VCF SKU as well. It's there for VVF at least. I'm not 100% sure if it's there without without either of those entitlements, but it is available in the lower end. Okay, we did that. Oh, yes, I hit that. We have NSX federated environment currently not in VCF. The second site is scheduled to be decommissioned. Okay. Okay, yeah. NSX Federation, I really have no information off the top of my head. I would have to ask a couple of colleagues or do some research on that, Ramon. So we'll take that one offline, and we'll try and get an answer to you about your question there.
Yeah, that's probably a good one to work through there, TAM. Like a little bit more complicated, right? So
Yeah, it does look a little bit more complicated. So yeah, that's probably a good idea. If you want to work through your TAM, get them to come into us or come into our colleagues here, and we'll get an answer for you. Oh, I was going to say that's all the questions, but we got another one popped up about ELM. Multiple ELMs in vCenter, multiple vCenters on ELM. If we move only a few, fleet management to centralized tagging. Yeah, so I'm not sure if the vCenter, yeah, so vCenter linking and then fleet management, tagging, and role management, they're essentially separate in VCF 9.1 now. The vCenter linking that we have in 9.1 really only gives you the single pane of glass view in the vSphere client. It doesn't do the tag and role replication that previous linked mode would have done through the VMDIR replication. So they're two separate features. So you can use one or the other or both together, because there's no longer a dependency on either. Okay, so that is it for me. There are no more questions. We will get a copy of this presentation and the recording sent out to you, like Andy said at the top of the presentation. And yeah, thank you.
Yeah, super. Thanks, Féidhlim. This was great content. I appreciate the interaction from everyone. Good questions, right? Help the discussion move forward. So we appreciate that. And just like was mentioned, you can go to the to the VMware TAM Services YouTube channel. All of our recordings are there, and then the slide deck you can get directly from your TAM. And so please join us next month when we look into Operations Manager operate, protect, and manage pillars. All right. Have a great rest of your day, all. Thanks.
Thank you.